This quick lesson is about equivalent ratios and using tables to help you find out equivalent ratios. So tables usually work best if you start with a small ratio in simplest form and are growing, but you can also do them if they're not, and I'll show you both methods. We can also use different kinds of tables. I'm going to show you two in today's lesson. So the first one I'll show you is a horizontal table. So if I have 3 to 4, I could write that as 3 to 4. But then I can go ahead and expand that out. If I have 3 to 4, I can go ahead and multiply that by 2, both the numerator and denominator. 3 times 2 would be 6. 4 times 2 would be 8. So I know that an equivalent ratio that I have to 3 to 4 is 6 to 8. I can find another one by multiplying by 3. 3 times 3 is 9. 4 times 3 is 12. So another equivalent ratio that I have is 9 to 12. I can keep going and get as many as I need. I have 3 times 4 gives me 12. 4 times 4 is 16. So I can see 12 to 16 is equivalent to 3 to 4. Let me go ahead and do just two more. I can go times 5. 3 times 5 is 15. 4 times 5 is 20. So 15 to 20 is equivalent to 3 to 4. Let's finish it off with 6's. 3 times 6 is 18. 4 times 6 is 24. So I see all these equivalent ratios that I have that are really all the same as 3/4. They're just in different forms. So let's say I had a question asking me if 3 to 4 is the same as what to 12. I could easily now look back into my table and see, well, 3 is my numerator, and then the 4 is my denominator. So in my denominator, I'm looking for 12. So in my denominator, I see that that 12 is here. So I can tell that 9 was the missing piece to make my ratio, my equivalent ratio. Now, example 2, I said that we can still do, even though I can see that I'm getting smaller. It still works, it just will look a little different. And we can do a horizontal table, but I'm going to show you what it would look like as a vertical table, just to give you an idea. If we did this, I can still start with 24 to 6. Now, it doesn't really matter too much which one's each column. It's more about being consistent. So here I'm going to keep 24 here and 6 here, but I just need to make sure that I'm consistent. And I need to grow out my table until I can get a 2 in this column. So I'm going to go ahead, and here I multiplied by 3, then 4, then 5, then 6, and that really was okay, but here I'm not growing. I need to get down to 2. So I'm going to go ahead and reduce these. I'm going to say what goes into both of these, and I can see that 2 goes into both of them. So I'm going to go ahead and divide them both by 2. 24 divided by 2 is 12. 6 divided by 2 is 3. And I can keep going. Now I can do a couple more. I can say what else would have gone into 6. 3 would have gone into 6, so I could have divided by 3. 6 divided by 3 is 2. 24 divided by 3 is 8, so that's another equivalent ratio. I also can divide by 6 because 6 is a common factor of 6 and 24. 6 divided by 6 would have been 1. 24 divided by 6 would have been 4. So now I'm getting to the point where I can't really do anything else because my only other factor is 1. So this table is just really not going to go on forever. And I have all of my equivalent ratios here that are all whole numbers. So if I look back to the question that I was trying to figure out, what would go here, 24 to 6 is 2 to what? Is what to 2? So 24 to 6. Now again, 2's in the denominator, so I need to look. I made my denominator column here, my numerator and my denominator. So my denominator column's here. When I look down, I spot the 2 with 8. So the ratio I'm looking for is 8 to 2, or in other words, 8 to 2. making that my equivalent ratio.